Okay, so we are on to 5.3, just radical equations. So we are going to do solving equations with just one radical term, and you will always follow these 4 steps. You are going to isolate the radical, square both sides of the equation, solve, and then check your solution, because sometimes you can have an extraneous solution. So to isolate this guy, we're going to go minus 5, you get the square root of 2x minus 1 is equal to 7, square both sides. So you get 2x minus 1 is equal to 49. Add 1 to both sides. 2x equals 50. Divide by 2. X is equal to 25. Then you plug that in and check that it works. So then that would be 5 plus the square root of 2 multiplied by 25 minus 1. So then that gives us 5 plus 50 minus 1 square root, 5 plus 7, 12. It works. And it doesn't always work, so check it. This one here, I'm going to add this guy over, and I'm going to subtract this one over to give me m minus 6 is equal to the square root of 2m plus 3. We'll square both sides. So this gives me m squared minus 12m plus 36 is equal to 2m plus 3. Subtract 2m, subtract 3, subtract 2m, subtract 3 to give me m squared minus 14m plus 33. This breaks down into a product to give you 33, which is 3 and 11, but it needs to add to negative 14, so it should be negative 3 and 11. So then this is m minus 11 and m minus 3. So m equals 3 or 11, and then we check. So here this would be 11 minus the square root of 2 multiplied by 11 plus 3 is equal to 6. So 11 minus the square root of 25 equals 6. And yeah, 6 equals 6. So this guy works. And then 3 minus the square root of 6 plus 3 is equal to 6. And then 3 minus 3 equals 6. 0 does not equal 6. So this guy is extraneous. So m equals 11 and only 11. Okay, next one. So we will add 8 to both sides. So the square root of 3y divided by 5 is equal to 6. Square, square. 3y over 5 is equal to 36. Multiplied by 5. 3y is equal to 180. Divide by 3. Y is equal to 60. We check. So then that would be negative 8 plus the square root of 360 divided by 5 is equal to negative 2. Negative 8 plus 6 is equal to negative 2. Check. This one we're going to add this over and add this over. So this becomes n plus 7 is equal to the square root of 5 minus n squared, squared, n squared plus 14n plus 49 is equal to 5 minus n. Add one of these, subtract a 5. N squared plus 15n plus 44. That results in n plus 11 and n plus 4 equals 0. So n equals negative 11 or negative 4. And we check. So then negative 11 minus the square root of 5 plus 11 is equal to negative 7. So negative 11 minus the square root of 16 is equal to negative 7. Negative 11 minus 4 does not equal negative 7, because that would be negative 15. Does not equal negative 7. So this guy doesn't work. Check. This is negative 4 minus 5 plus 4 is equal to negative 7. Negative 4 minus the square root of 9 is equal to negative 7. Negative 4 minus 3 is equal to negative 7. Negative 7 is equal to negative 7. Check. So n equals negative 4, where the other solution is extraneous. Now, our last part of this unit is solving equations with two radicals. It's essentially the same, but you have to decide which one is more complex, and you might have to square more than once. So the first one is easy because they're both just two radicals chilling out. We're going to square both sides. This gives us z plus 5 is equal to 2z minus 1. It's just classic solving, so we need to make sure that we get all the variables to one side and all of the constants to the other. So then we get 6 is equal to z, and we check it. So the square root of 6 plus 5 is equal to 2 multiplied by 6 minus 1. This is the square root of 11 is equal to the square root of 11. It works. Okay, this one, and this is the more complex because there's more going on inside of it. Obviously, this one looks a lot simpler. So we are going to isolate this one by subtracting the 5 over. So it gives us 2 plus root 3x equals the square root of 5x plus 4. Square both sides. So that gives us, I'm going to write this out now for the multiplying. You don't have to if you don't need to. This gives me 4 plus 4 root 3x plus 3x is equal to 5x plus 4. Then I'm going to isolate this radical, so subtract 4, subtract 3x. So that gives me 4 root 3x is equal to 2x. I drew a z right there. That should have been an x. That's interesting. You can also divide by 4 here, but it's not totally necessary. I'm choosing not to because it makes more sense to me to save it until after I square things. So you square both sides. That gives me 16 times 3x is equal to 4x squared. This is 48x is equal to 4x squared. I'm going to subtract this over. And this leaves me, and I'm going to factor, and this gives me 4x on the outside, so x minus 12. So x equals 0, or x equals 12. I'll leave you to check those, but I will tell you that both of them work. This one's easy to see, and then you just check that one really quickly. I'm just out of room. So if you have room, do it. If you don't, don't. Solving problems involving radicals is easy in a sense that you just have to make sure that you are using real life context to make sure that it works. And you can either solve for the variable first, or you can just plug in the value. In this case, if with our formula, the energy coefficient, energy kinetic is equal to 1/2 mass times volume velocity squared. I'm jumping back and forth between math and science. EK represents the kinetic energy, so 28.8 is equal to 1/2 of the mass 0.4 velocity squared. 28.8 is equal to 0.2 velocity squared, divide. That leaves me with 144 is equal to velocity squared, square root, and you get 12 meters per second is equal to velocity. And I'm only using the positive because I am looking for speed of acceleration going forward. All right, that is it for this section. If you have any questions, please let me know.